So you were just introduced to the concept of function notation. And what we want to do right now is we want to evaluate and interpret function notation. Okay, so here's how you read this. This is a of x. You read that a of x. That's a function a of x. So a of x equals 2x minus 4. It looks like multiplication, but it's not. Context is important. Anytime something's written like this, your brain will begin to recognize that as function notation. So a of 7, what we looked at it just a second ago, is whatever is in these parentheses is what we plug in for x. Instead of x, we're going to write 7. So a of 7, instead of 2x minus 4, would be 2 times 7 minus 4. Wherever we see a 7, we write an x. So 2 times 7 is 14. 14 minus 4 is 10. So a of 7 equals 10. That means the function evaluated at 7 equals 10. Okay? B of negative 2. Well, up here we have b of x equals negative 5x plus 1. So b of negative 2 means wherever we see an x, we're going to substitute negative 2. Instead of x, we're going to write negative 2. So we're going to say negative 5 times negative 2 plus 1. Wherever we saw an x, we wrote negative 2. So we got 10 plus 1, and we get 11. So b of negative 2 is 11. This means the function evaluated at negative 2 equaled 11. All right, you've seen 2 examples. Why don't you pause the video, you try b of 0 and a of negative 4. I got b of 0 is 1. When I plugged in 0 for x, I got 1. And a of negative 4 is 12. When I plugged in negative 4 for x into a, I got negative 12. Now, what does all this mean? This has to do with points on the coordinate plane. Every point on the coordinate plane has an x value and a y value. Well, f of x, function notation, is often used instead of y. F of x is the same thing as y. So we could say that a point has the coordinates x and f of x, which means it has an x coordinate and then it has a function value at the x coordinate. Every x coordinate has a y coordinate. So basically whatever is in your parentheses is x, and then what it equals is your y value. So g of 4 equals 2 means that whatever's in the parentheses is 4. That's what we're plugging in. And when that's our input, and we plug 4 in, we get 2 as our y value. So this is telling us an x value and a y value. So p of 6 equals 0. Well, I'm plugging in 6. My input, my independent variable, my domain, that is x. So that's telling me my x value is 6. And when I plug 6 in, I get 0. So my output, my y value, is 0. So you use what we've done there, look at these next 2 examples, and translate them into coordinate points. C. If f of negative 3 is 7, that means my x value is negative 3. And when I plug that x value in, I get a y value of 7. So my point is negative 3, 7. H of 0 equals negative 5, means my x value is 0. That's what's in the parentheses. And my y value is negative 5. Now here we're going to be given the coordinates, and we have to sort of go backwards. They're giving us the point negative 8, 9, and they want us to use the function notation. So this is, let's see, 1, 2, 3, 4, 5. Yeah, this is the point, negative 8, 9. Okay, they tell me that my name of my function here is f. Functions are often f, g, and h. F probably for function, and g and h just because they're close. But here My x value is 8, so that means negative 8. F of negative 8, and my y value is 9. So the function evaluated at negative 8 equals 9. Next, I have the point negative 2, 5. That means the function evaluated at negative 2, when I plug negative 2 in, I get 5. So f of negative 2 equals 5. I'll do one more. 4, 1. My x coordinate is 4. My y coordinate is 1. So when I plug in 4 for x goes in the parentheses, f of 4, when I plug that in, I get 1 for my y value. You pause the video, translate these last two. So for D, they gave me the point 10, negative 3. That means f of 10 equals negative 3. E, they gave the point 16, negative 7. F of 16 equals negative 7. Remember, x goes in the parentheses. It's what you're plugging into the function. And then your y value is what it equals, what you get after you work the problem out.